Hi everyone, this is Shayan and welcome to the first video in a series of short videos where we'll look at actual SAT problems, and I'll try to give you any shortcuts and tips wherever I can. So feel free to pause the video at any point to read the question on your own, because mostly I'll be reading the question. Sometimes I'll only read like the last line of a question because that's only what we need, but if you feel like you want to read more, you can pause. So this one right here is from the 2020 March US exam, and let's just start from the very last question. So this is a scatter plot. The question says, what is the number of computers for which the line of best fit predicts a value less than the actual value? So this is a very common question where they ask you either to count the number of points above a line or below a line in a scatter plot. In this case, we have to count the number of points above the line. Why? Because the line itself is the predicted value, remember, and the points are the actual value. So they're saying the number of points for which the line predicts a value less than the actual value. So we'll count these points: 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a total of 9 points for which lie above the line. So that's our answer. Question number 37. Based on the line of best fit, the estimated value of a 6-year-old computer is $1,000. So all we have to do is just read the value. So from here, from the graph, we'll go and read the value on the line. Because remember, whenever they say the estimated value, always read the line. So in this case, this is just going to be 15. That's the number of, that's the value of K. That's the value when the age of the computers was 6. Let's go up to question number 36. A linear function is defined by this cx plus t, and we actually have 2 points on the line. Remember, whenever you have something like f of one thing is equal to something, and then f of another thing is equal to something, so they're basically giving you 2 points that lie on the graph of this line. And now what are they asking for? They're asking for c. So you need to identify what they're asking for. Are they asking for the slope? Are they asking for the y-intercept? Or just the value of another point? So in this case, they're asking for the slope, because whenever you have an equation in the form y is equal to mx plus c, m is the slope. So how do we find the slope? Well, the formula for the slope of any line is the change in y over the change in x. This is how much does y change for every one change in x. So what we'll do is, for the denominator, we'll subtract the two x values. So 100 minus 50. Anything that's inside the f brackets, that's the input. And then for the numerator, we'll do 38,000 minus 27,000. And this is just going to be 11,000 over 50, I think. And that's just going to be 220. Yep. So there you go. We've solved these. Actually, I think we have time for one more question. Let's try and do question number 35. Yeah, it's pretty simple. So we just have a parallelogram here, and they're asking us to find the area. So remember, the area for a parallelogram is equal to the base times the height. So you look at the diagram, you see, do we have the base and the height? Yes, we do. The base here is 10. This is the length of the base of the parallelogram. And this, the height, remember, is always perpendicular. So this is the height and not this 5.25. So make sure you multiply 5 times 10 to get a 50. So that's it for this video. I'm trying to keep these as short as possible. So I hope to see you in the next one. Thank you for watching.